Good afternoon, everyone. My name is Dr. N.A. Ajekigbe. I'm your facilitator on ECHO 254, Statistics for Economics 2. You are welcome, everyone. Today, I'll be discussing issues on Economics 254 with Statistics for Economics. This is a repeat of the presentation that was made last week, because some of the attendants told me that they did not have a good audio output of what transpired last week. So I need to present it the second time. Now, quickly to the business of the day. I'll be sharing quite a number of things with you on economics, Statistics for Economics 2, ECHO 254. Like I told you, my name is Dr. N.A. Ajekigbe, and I'll be sharing on the screen with you my email address and my mobile address. Feel free to get across to me. So let's get to the business of the day quickly. So as you can see on the screen, the topic, the title of the course is Statistics for Economics 2, is ECHO 254, and I'll be introducing to you this course today, and we'll take the first module of the course. Now, you can see my email address on the screen, alabaajekigbe@achievers.edu.ng. The mobile address is 0803-706-2508. So feel free to copy and the mobile address and the email address and interact with me. You are all welcome again. Today we will take the introduction. We'll take the introduction, and like I said, the first module of the course. Now, quickly to what we have for the business of the day. Now, the outline that we have for the course, we have the course outline. The course outline is shown here. The course outline is shown here. And of course, like I said, the title of the course is Statistics for Economics 2, ECHO 254. The course outline, you have the course outline, we have the introduction, the course content, the aim of and objectives of the course material, and the assessment and other details. The introduction, take you to introduce the course. The course is a 3-unit course, an undergraduate course, a one-semester course, and of course, you students will be taken through how to study, use, and apply statistical analysis in economic research, and analyzing and providing solutions to economic problems. Then the course will still introduce you to details in the course of the study. In the free facilitation, I will introduce you to details of the course materials and how to work through them. It will also give you guidelines on how as students you can achieve the overall aims and objectives of the course. Now, the course content. The course is divided into 5 modules, and the first one that will be taken will be today will be probability distributions. Subsequently, we'll be looking at hypothesis testing, sampling theory, t-test, f-test, chi-square analysis, and simple regression analysis and its applications. Then, of course, we will still go ahead to the give you the aim of the course. Of course, the course is intended to provide students with an in-depth understanding of tools in economic analysis, in topics, to highlight those topics in details. We look at the basic concept of probability and probability distribution and its calculation. We will see familiarize ourselves with the knowledge of t-tests, the hypothesis testing. Then we'll stimulate the students' knowledge of sampling theory. Then the other aims of the course are to give you an understanding and the calculation of t-tests, f-tests, and chi-square tests and how you apply them. Then the last in the module will give you an understanding of simple linear regression, its application to practical economic problems, and how to interpret your results. Now the course objectives still goes further to say, okay, in this course of these interactions, each of these modules have their own specific objectives, and at the end of the course period, as students, you'll be expected to understand the meaning and practical applications of each of these specific areas that will be mentioned in course of this presentation. Then, when we're looking at the specific objective, if there's a course guide, which I will give you the URL, the link to how you can assess the course material in the subsequent slides. But specific objectives of the course are to give you an understanding of probability, different types of probability distribution, and analysis of the probability problems. Number two is to give you an understanding of continuous random variables such as continuous probability distributions and distribution functions for continuous random variables, as well as higher probability distributions. Then we'll still look at hypothesis testing procedure, type 1 error, type 2 errors. We should distinguish between them and how to calculate between two-tailed tests, one-tailed test, and two-tailed tests. Now, in the course of these interactions, we have 8 sessions, and 8 of those sessions is taken from the 5 modules that you have in the course. So if you take a look at the page 6 of the course guide details, which I'll give you a guide on how to access it later, the 5 modules will come. The first session that we are on now is the introduction and the module 1, which we are going to cover today. Second session will take you through module 2. We'll continue in the third session with module 2 and 3. And in the first session, we'll still take you through module, finish up with module 3. Then the fourth session will take you through module 4. Continue in the 6th session, we will still take you through module 4 and 5. Then the 7th session, we'll look at the module 5, and the 8th session, we'll look at the 5th module, which is a continuation and the summary. And of course, we'll look at some practical applications and calculations and how you can assess, how you can have a thorough understanding of this, the topic, all the topics that will be treated here. Now, assessment details. As in the course guide, we have the assessment, continuous assessment to be taken consists of 30% and final examination 70% as stipulated in the course guide. Now, I told you before that the course material, you can access the course material or the course guide on Science for Economics 2 and the website you can see that you see on the screen. Now, the textbooks, various textbooks, they are stated, there are different kinds of textbooks that is stated in the course guide. Assessing the course guide, you'll be able to look at some of those textbooks, and you should be able to go through them as much as you can lay, as many as you can lay your hand on, kindly go through them and and so that you give you a deeper understanding of the entire course. Now, looking at the topic that we have for today, the module one. The module one, like I said, covers probability and probability distribution. And we have 3 units in this module. The first unit is analysis of probability distribution. Continuous, we'll still be discussing the unit on unit 2, continuous random variables and other probability distributions. All these 3 units will be taken together in course of this presentation today. Now, to give you an understanding of the probability and probability distributions, you need to understand the concept of what's the concept of probability. And we take it, we'll begin by saying that in any random experiment, there's always an uncertainty as to whether the events will occur or it will not occur. So for a particular a random experiment, it's either there's an occurrence or there's no occurrence. So we define probability as a measure of chance, and probability with that the event will occur can always be assigned between 0 and 1. The probability that the event will occur is 0. The event will not occur at all will be 0. And the probability of certainty is 1, that the event will occur. Now, within this continuum, between the 0 that the event will never occur, and the event is that certain that will occur, there's a range of probability, that a range of probability that the event can assume. Now, in estimating the probability of that an event will occur, is that I will go through the classical approach, of course, or the frequency approach. Of course, the 2 approach comes out to yield the same results. The classical approach, you say if an event occurs in H different ways out of a total number of n possible ways, then the probability that the probability of the event is H all over n. So, and if you look at, so what we are just doing here is that, okay, the total number of different ways that the event will occur, H, then the total number of possible ways that it can occur, n. So it's just we're taking a fraction of, okay, how many different ways to occur and the total number of possible ways it can occur, H over n. The same way, if you look at the frequency approach, after n repeated experiments, if we are talking of when n is very large, then if an event occur on H times, the probability that the event will occur, which is more or less an empirical probability, now you are doing an experiment, is H all over n. That means the probability that will occur 8 times over the total number of possible ways that occur is still O over H all over n. So you see now that whether you use the classical approach in determining your concept of probability, or you use the frequency approach, it comes out to the same results. Now, the meaning of probability distribution. When we look at probability distribution or probability functions, as the case may be, it can be a discrete or continuous probability distribution. So if we are taking the occurrence of an event as a random variable, random in the sense that when you carry out the experiment, there are different ways the occurrence of the event can come up. Now we take the total number of the times that it can occur, the total number of possible ways that it occur. We take it as a sample space. So we assign a number denoted by capital letter X. So or Y in most cases for a random variable. And the number, so we say, for example, the number of occurrence of X. When X, if we give an example now, when X is when a coin, a fair coin is tossed twice. So it's given in this table below. And I said, like the random variable X, the random variable is denoted by X. So when X occur twice, then the random variable will be 2, as you can see in the table here. Then if head occur first toss, and if just one head occur, we have head occurring on the first toss. Then we have the random variable being 1. Then if head occurred at the second time, the first is head and head, and the first is tail, and second one is head. Then that means what we have, the random variable will assume a value of 1. If head does not occur at all, that means we have tail occurring twice. Now we have the random variable being 0. So what it means is that head, the random variable can assume value of 0, 1, or 2 in this case. And the probability that head will occur, which is f of x now, as you can see in the table, that table 1 here is such that if head occurs, first toss, second toss is 1/4. Heads occurring first time, in the first toss, we have 1/4. At the same time, heads occurring, the tail first occurring and the head occurring at the second time, we have 1/4. Then the heads will not occur at all is 1/4. Now, discrete random variable. What do you mean by a discrete random variable? A discrete random variable are the one that takes on infinite, finite, uncounted or countable infinite number of values. You can assume an integer value. So like you have now, the random variable here now, x in the table above here now showing 2, 1, and 0. Now a continuous random variable takes on non-countable infinite number or assume a value within an interval. What it means is that you need to, in subsequent studies, in your research, you'll be presented with different kinds of data. Some are discrete, some are random, some are continuous variables. Take for instance, if you are counting the number of cars, the number of cars can only assume, or maybe houses can only assume discrete values, 1, 2, 3, and 4. Meanwhile, if you are taking maybe the height of a particular set of people, you can have 1.2, 1.345, and the like, or volume. So those ones are referred to as continuous random variable. So you should be able to distinguish between discrete random variable and continuous random variable, because how you treat them in your studies will be very different, and you see it as we go on in this presentation. Now, for a discrete random variable, I told you earlier on that the discrete random variable here is denoted by x. So if x, let's assume that probability that the air will occur when a coin is tossed twice, like you saw in the other table, that x can assume values like x1, x2, and xn in the first toss, second toss, third toss. When you do this, when you carry out the experiment, so the probability that x will take place is given by f of x. So, and like I told you the other time, the random variable itself is denoted by capital X. So the value that it assumes is x. It can be x1, like you saw in the other. It can be 0, can be 1, and it can be 2. And the f of x that you have is the probability. There are different associated probability associated with each of those random variables. You saw 1/4, 1/4, and 1/4. When you toss the number that the probability that head will occur. Now, coming from that table 1, the discrete probability distribution that is given now, that okay, assuming that head does not occur at all. So you have f of x here now. We said the random variable x takes value of 0, 1, and 2. Now that the probability that x will assume a value of 0, as from that table we take 1/4. And the probability that x will take that occur on the first toss, that's we have head, tail, and the second toss, tail, head, it will be 1/4. When you add the 1/4 together, you get the 1/2. So the probability that head will occur just one head will occur, will be 1/2. That's half. Now the probability that we have two that S will occur. That means S will occur on the first toss, and the second toss now we have is taking 1/4. So you see two S occurring at a time. So in general, probability distribution function is greater than 0, and is assumed, like I said, it's assumed a value of between 0 and 1. And the summation of all this probability, that if you add 1/4 to 1/2 to 1/4 in any experiment that you carry out, the summation of that probability is equals to 1. So the distribution is discrete random variable, whereby summation probability of x as a random variable taking a value maybe all over the mean will be equal to 1. It runs through possible values of x. Now, moving to the next slide now, we have properties of discrete probability distributions. And the very first one that you see that it is non-decreasing. Then limit of x, as x tends to infinity, I mean f of x that I've told you the other time will be equal to minus infinity will be equal to 0. That means x cannot go below 0, and limit of x as probability of x tends to plus infinity is equal to 1. It still bothers with the fact that it will always assume either between value of 0 and values between 0 and 1. Now it's continuous to the right. I'll give you an example of what this in the course of the study. In the sense that probability cannot be negative. It can be negative. So where x is any real number, hence the distribution functions has this property that we have mentioned. X is a real number and is an integer, for instance. Now, then distribution function for a discrete random variable x can be obtained from its probability function for all x in between minus infinity to plus infinity. So the summation, like I've said, the other one is like I said, is equal to 1. And f of x, probability of x is equal to, if f of x is equal to probability of x, which is less than or equal to, can be less than or equal to 1. So where the sum is taking over all the u values, the values of the values of the random variable that we have, then we have the u, I mean the mean of those, the summation. Now we have it's assuming value less than or equal to x. So the set of all possible values is discrete set, in the sense that all the points are isolated points. That means, like I said, it's an integer. Then there are examples of discrete probability distribution used in statistical modeling. Like you can use Poisson distribution, binomial distribution. I will explain this one in course of this presentation. Poisson is more or less a count distribution, while binomial is more or less is a probability distribution whereby you have if the probability that the event will occur is p, then the probability that the event will occur is 1 minus p. Now we'll see give further examples. Now going forward, we'll look at continuous random variables. Now continuous probability distribution rather. So a non-discrete random variable is said to be continuous if the distribution function can be presented as f of x is equal to the random variable x less than or equal to x. Now, in case of continuous probability distribution, rather than using the summation notation, we use the integral, because more or less is like a normal distribution is a Bell-shaped distribution. So we integrate from minus infinity to plus infinity, where x will assume different values within that range. Now, for properties of continuous probability distributions, f of x is greater than or equal to 0. So summation of x, like I said, if you integrate between minus infinity to plus infinity, we have f of x dx is equal to 1. What it means is that you can't, it is difficult, like on random, it's not possible to get in, as in have it in under discrete random variable. Continuous random variable cannot assume integer values that we have now. So to get the probability of a continuous random variable, we integrate. You understand this in subsequent by the time we do the practice questions. Hence, if x is a random variable, then it has a probability density function f of x. The probability that x takes on a particular value is 0. X cannot assume a specific value, but a range of value. Then the interval probability that x lies between two different values, a and b, is given by probability of x is greater than a but less than b. So the random variable can always assume the probability between x and b. So in order to capture what the probability is, like I said, we integrate. So for those of us who have knowledge of integration, it will assist you later to know how to calculate this continuous probability distribution values. Now, examples of continuous probability distribution are normal distribution, like I said, is a bell-shaped distribution, and of course, a chi-square distribution. So these ones, unlike discrete random variables, you will be able to capture, if you have a normal distribution, you'll be able to capture what the value of the probability is in a continuous random variable. Now, moving forward now, moving forward now, we said that this general probability distribution has the following properties. Now, probability cannot be negative, or it cannot be greater than 1. So that means it can always assume, like I said, between 0 and 1. That's why see probability of x is greater than or equal to 0. That means 0 when it's certainty, or less than or equal to 1. That means probability of x cannot be more than 1. When you have two mutually exclusive events occurring, that okay, maybe the probability that if the event it can never occur is 0. So what it means that the probability that the event cannot never occur is 0 and cannot assume any other value. Now the probability that the event will occur, is certain to occur, is 1. Then the sum of all the probability values of x must be equal to 1. There's also the probability or certainty that one of the mutually exclusive outcomes will occur. That means it can be 0, it can be 1, it can be between the range of the 0 and 1. Now, the summation now, if you want to take for discrete case from minus infinity to positive infinity, probability of x is equal to 1. The same thing go for this continuous random variable, continuous case, whereby you integrate from minus infinity to to positive infinity, all resulting in a total of 1 if the event is certain. Now, moving forward now, if you have a curve, a bell-shaped curve that is a normal distribution, the area occurring under it can be captured by the instrument of you integrate from A to B. Now, if you have from A to B, you have an f of x, you integrate from A to B dx. That means probability that x will assume between the value of, is ranging between value of A and B, is x is greater than A or x is less than or equal to B. Now, in your maybe statistics 1, economics for statistics for economics 1, you probably will have been calculating parameters like the expected value, that's the mean. You calculate the variance and the standard distribution, deviation. Now, in the same way here, we say expected value of x, expected value of the random variable for a discrete case, we say is equals to the value of the random variable multiplied by the probability of X. So when you take the summation of that for a discrete case, with the summation that we as you can see on the screen now, you find out that the random variable, this discrete random variable, when you take the total, the mean will assume the total of total of X multiplied by probability of X. The same thing goes for continuous random variable. When you integrate from X to from minus infinity to positive infinity, as you can see with the cursor now, we have probability of X, the X. So that will give you, so taking that one forward, you can give you an example that assume you have a constant function B, and you are given this above function where X ranges from 0 to 1. This example is taken from your student guide. You can get it from your student guide, but at the same time, I brought it here to demonstrate what I've been trying to explain to you in terms of continuous random variable. For a discrete case, it's straightforward. You can always calculate what, like I mentioned in the previous slides, you can always calculate the probability. Take for instance, if I take you back to slide 12 and 13 now, you have the random variable assuming value X, and then you have in this case now you have the random variable assuming value of 0, 1, and 2. Now, if you want to calculate the mean, will be the summation of X here that you see here, X here for a discrete case now, X here multiplied by f of X, which is the probability distribution, probability of that head to never occur in this case. Then you take this X here multiplied by the probability of that's f of X, then take the X again multiplied by f of X. That will give you, and when you sum it all together, that will give you the mean. That is the average that you have. So going back to our example, which is slide 19 now, and you can see this slide. If I take the example that I given in the previous slide now, that will give you the mean that you have here now. Of course, if you can calculate the variance too, you can calculate the standard deviation. We will get there now quickly. Now, if you take the function that we have now, integrating, when B, we assume that B, we already told you that B must always be greater than 0. That's the property 1 in equation 1. So f of X must satisfy equation 1, property 1, equation, and it must satisfy property 2. So for a continuous random variable now, when you integrate from minus infinity to positive infinity, f of X the X, integrating from 0 to 3, just as we have here, that is the range now of the best shape curve. This one will be the integral for some of us that knows how to, for some of us that have the knowledge of integration, that will give a value of 9b. Now, solving for what B will be, assuming that B will take a value of either 1 or 2. If X ranges between 1 or 2, so once our B, we say, okay, our B is a constant now. Now we say it will give us this integral value that you can see here. Now, assuming that X will now range between 1 and 2, here now, the solution will now be 7 all over, now be 8 all over 27 minus 1 all over 27, which will give you the probability. What means that the probability will now be, the answer will now be 7 all over 27. Now, going forward now, there are other probability distributions in course of this study. And as much as possible, I will try as much as possible to ensure that I give you a preview of this. But reference to page 30 or 37 of core guide details, you have the formulas and applications. Now, other probability distribution, apart from continuous random variable and discrete random variable that I've mentioned, earlier on, you will have a multinomial distribution, hypergeometric distribution. These are higher level distribution. They are using all of them are using empirical modeling, and you are likely to come across them in course of your study as economists. Cauchy distribution, gamma distribution, beta distributions. If you refer to page 30, between page 30 and 37 of your course guide, you find out that a multinomial distribution is defined there as a probability distribution that it analyzes binomial distribution, and it's also called multinomial distribution. You see the equation on page 30 of your this thing. I will not bug you this equation, but if you take that reference, you'll be able to see determine exactly what a multinomial distribution is. But the main concept is given on the on page 30 there. Now, hypergeometric distributions. Now, hypergeometric distribution, like I told you the other time, we have binomial distributions, we have Poisson distributions. If you want to, take for instance in terms of count model, if you have a count model, these hypergeometric distributions are applied in modeling Poisson distributions and binomial distribution. Then for Cauchy distribution too, we still have is more or less what to. So of course there are uniform distributions too, and the is used in most cases where you take samples that assuming that from a deck of cards you want to pick the likelihood of drawing the club or the diamond or the spade from a deck of cards, you'll be able to determine what the distribution is. The same thing goes for the next one is the gamma distribution. For gamma distribution, is more of two parameter distributions and it's of the continuous probability distribution. Then for beta distributions, then it's also a family of continuous distributions. Now, this distribution can be used to calculate and analyze different models and measure of central tendency, whether it's a mean, the median, and the mode. If I take you back to slide 17 now, where I say, you can calculate the mean. You can take the mean, the expected value, you can get the variance. After having taken the mean, then you can, as much as possible, take the square root of that, and you get the standard deviation. All of these measures can be calculated from whether you are applying your continuous discrete random variable or continuous random variables. So in summary today, we have looked at discrete, we have looked at what the concept of probability is. We have looked at how do you define probability in terms of classic measures, in terms of frequency measures. We have looked at what a random variable is. At the same time, we have looked at what a continuous random variable is, what a discrete random variable is. Then we have looked at the properties of the two random variable, whether it's discrete or continuous. At the same time, we, as much as possible, look at not only how to calculate the probability distribution for the random variables. At the same time, we have looked at how to calculate the probability distribution for both the discrete random variable and the continuous random variable. Then, like I mentioned the other time, if you want to take the variance or the distribution, as we have in slide 21 now, is the summation. Like this is the formula for the variance, as you can see, that is denoted by this measure is a measure of dispersion. That means the deviation from what the value of x is when you take the mean. So x minus, like you have x minus x bar square. Now x, you now, assuming that the mean of the population, you get to know this one later. Then at the same time, you, the variance for a discrete random variable, where the summation coming up to x minus u into probability of x. Then for a continuous random variable, you integrate, then you get the variance. Then if you take the square root of that, you come out with the standard deviation. So thank you very much. I don't know, I will end here and allow for questions, allow for interactions, because we have less than 10 minutes to end this. So if you have questions, kindly let me have your questions before we stop the discussion. Please mute your speaker and let me have your questions. Hello? Yes, I'm listening. I know.
No, sorry, sir. No question, sir.
No question.
I'm okay.
Okay. Yes, now, I want to ask, when is it convenient for you people to have this class? Because I've not been having the required audience. Is this timing convenient for you?
The truth is that it's not. This Tuesday is not, sir.
It's not.
Always better. Yes, sir. It's always better around that Thursday, Friday, weekend.
Thursday, Friday. Weekend.
Saturday, Sunday, or maybe Sunday.
Okay, yes, Sunday, Saturday. Okay, all right. I'll take note of that and adjust the timetable.
Thank you very much, sir. God bless you.
All right. Next week we'll be going to. I will be discussing module 2, and module 2 will give you the preview of what you are likely going to, how you're likely going to be applying what we have studied today.
Okay, sir.
DMN is raising up his hand. Can you mute your speaker and let us talk, please?
All right, sir. Good afternoon, sir.
Afternoon.
Yes, sir.
Were you able to? Excuse me. Let me ask you. Were you able to hear me clearly? Because last week people that came on said they cannot hear me clearly. Were you able to hear me today?
Yes, at least the little time I was here, I heard everything.
Then the other thing I want to ask is that the screen, were you able to? I shared my screen with you. Are we able to see the slides?
Yes, I saw your slides, sir.
Okay.
Okay. Really good.
All right, but one major thing I need to let you know is that there is this course material. I've given I know you probably have the URL to download it. There is a course material there. Everything is taken from your course guide, except that I just add a few of my own ideas to it. Then there are books that for reference materials. Surely before we, as we go on, I'll try as much as possible to bring up tutorials so that we have an idea of, okay, how do you calculate a discrete random variable, discrete probability distribution, or how do you calculate a continuous probability distribution. The mode of calculating them are different in most cases. Okay, let me listen to your question. Hello? Can I listen to you?
I just wanted to suggest something because you asked if the time was.
Okay, timing.
Yes, the timing. I feel it is good enough. Why I came late a bit, which I'm sorry about, was because I didn't get the information in time. I thought this course was for Thursdays, right? So yeah, I was just going through my e-learn portal now, and I saw that you already sent a message to my
sorry
private
about
message.
that. Sorry.
Exactly.
The challenge that we have is that we have 8 sessions, 8 weeks, and we are a little bit behind schedule. So what I've subject to agreements, because I need to have your own input. Since I not said, I don't know whether that agreement will be convenient for you too. You said Thursday will be okay, Friday will be okay, but I want us to leave out Friday because some of us will probably want to go to mosque, Jumat.
Yes.
Okay.
So we want to leave out Friday, so we can now settle for Thursday, anytime between Thursday, Saturday, and Sunday.
Sir, may I bring to your notice? Thursday, we have other lectures that are fully booked for Thursday.
Okay,
Exactly.
so
Because
when are you suggesting now, please?
I just feel like
Sir, if your Sunday is free, sir, I don't mind, sir.
Sunday, when on Sunday? Hello?
Sir, I don't know if you are a Christian or a Muslim, sir. But
I'm a
I am a
Christian.
Christian. So I go to early morning service.
Okay,
So
can we
by
meet
10 to 11,
in the evening on Sunday?
that would be very well. Okay,
Anytime
sir.
from like maybe 3, 4.
God bless you, sir.
Okay. I will take. I don't know whether that one is agreeable to DMN. Hello?
I was trying to type it in message, but since
Okay.
we're done ahead, so I feel like
are you okay with the Sunday?
Sunday is fine. I mean,
Okay, all right. We'll take it down that Sunday from the hours of maybe like 2, 3 to down 6 o'clock. We can just fix an hour there and quickly do what we need to do.
Exactly. I think that's fine.
Perfect.
And,
Perfect, sir.
yes, I think that's
All
fine.
right. Initially, I've scheduled another meeting for Thursday around this 2 to 3 p.m. Would that be okay by
Yes,
you?
sir. 2 to 3.
Yes.
For Thursday.
Yes, Thursday is fine.
Okay. Well, we'll take on module 2 on Thursday, please.
Okay, sir. Okay, sir. That will be a good.
All right. So please, I know that we have about 336 students in this class. I'm aware that it will not be convenient, so I will go and upload this presentation and the slide on your website so that others will be able to see it and maybe possibly ask questions. So the way I want to suggest that going forward, for every meeting we have like maybe if we come early enough, like maybe like 40 to 50 minutes of presentation, there are about 10 minutes of questions. Are you okay with that?
It's okay, sir.
All right. So thank you for having me here.
Thank you too, sir.
All right, you are welcome. So till Thursday now, 2 to 3 p.m.
Yes.
Okay, please let's do that Thursday today, then Sunday, because we need to cover up for the periods that we have missed.
Okay, sir.
I think maybe we'll take it this way. Once we meet now, we'll agree on what the subsequent meeting will be. Hello?
Okay.
So I think that will be okay. Once we meet on Thursday now, we already agree on the Sunday meeting anyway.
Yes, sir.
So once we finish the Sunday meeting, we agree on the next meeting.
Okay.
Then I will send a notice, 24 hours. That's even the regulation of the school. I always give a notice 24 hours before the meeting.
Yes.
Are you okay with that?
Very well, sir.
Okay, as much as we have more members joining us. So thank you. I have done this presentation last week for this first presentation, but because I got the response that most people did not hear me when I was speaking, and they did not even see.
We did not hear. Yes, I was there.
So that's why we need to repeat this. So, and I think today's own is clear enough.
Okay, very, very clear.
All right, thank you very much. You are welcome. I will be off now.
Thank
so
you,
till Thursday again.
Have a good day, sir. Thank you.
You are welcome. Thank you very much. God bless.
All right, sir. God bless you. Bye.